Good morning, class. Today is Monday, May 18th, and my gift to you today is that we're going to do some pretty easy math because the science that we're doing is kind of a lot. So it might feel like a lot of work today, but it shouldn't be too difficult. So let's start. Again, as I've said a lot of times, we're going back through the book. We're doing pages that we hadn't done at the beginning of the year to give ourselves a review of place value, and I cannot encourage it enough. Over the summer, do yourself a favor. I want you to imagine that every hour of math practice that you're doing, imagine that that's $1,000 going into your future self's bank account. It's not immediate. You're not going to get that money for another 15 years, but I can almost guarantee you that every hour you spend on math will be another $1,000 in your bank account somewhere someday. Because just when we're good at math, we have so many more job opportunities available to us, so many more life experiences available to us, and I can't encourage you enough to keep practicing those mathematics skills. So place value, adding, subtracting, multiplying, dividing with whole numbers, decimals, and fractions. This is part of that practice. Feel free to use iExcel throughout the summer. Feel free to use the blank pages in this book as extra practice. This particular practice is different forms of numbers and place value on pages 21 through 23 in our Ultimate Math Notebooks. If you don't have your Ultimate Math Notebook, my expectation is that you're doing this assignment on a separate sheet of paper, sidewalk chalk, a whiteboard, or any form that you find to work for you. So number one, you need to write the following numbers in standard form. So let's review kind of what these word forms or what these different forms of numbers mean. I feel like this is very zoomed in on me and I have no idea why. So my apologies for that. So let's just even take the number 123, 1, 2, 3. So if I take the number 123 and I write it like this is actually called standard form. And I like to think of this as the way that we see numbers most of the time, right? We don't usually see numbers in expanded form on the street when we're purchasing potatoes or video games or whatever. So this is standard form. If I want to write it in written form, that is exactly as it sounds, with words, not with actual digits and numbers. So this would write 100. 23, like so. And then if we're doing expanded form, we're taking that number and we're separating it by its place value. So that would be, in the easiest form of expanded form, would be 100 plus 20 plus 3. Okay? I could also remember I could do this with my powers of 10. Remember, when I have a decimal, when I have an exponent, that doesn't mean 10 times 2. That means 10 times itself this many times. In this case, it's 10 times itself twice or 10 times 10. Another way to look at this, if we have a 1 or a power of 10, is it's a 1 with this many zeros. So this would be 100, for example. So I look at the number of zeros in each of these. So this expanded could be 1 times 10 to the second power, and I know that because there's 2 zeros. My front digit is a 1, plus 2, because 2 is my front digit. We've done a lot of practice with this on this year, so this should not be revolutionary news to anybody, times 10 to the first power, because there's only 1 0, plus 3. I could do 3 times 10 to the 0th power, but that seems a little unnecessary. Okay, so that is standard, written, and expanded form, just a review in case that's unsure for anybody. So write the following numbers in standard form. That means take them out of their expanded, take them out of their written, and write them as that goes. I'm going to just let you pause, do these questions on their own because they should be pretty easy for everybody, and I will show you the answers. So if you're back here at this point, I'm assuming that you've answered this green circle. Our answers are number 1, 5,016,421. Number 2, 6,950,006. Number 3, 901,030. Number 4, 62,748,103. And number 5, 7,323. Write these numbers in their expanded and written form. So you could do this with the exponents. I'm going to give you the way that's written here, and then I'm going to give you with the powers of 10. So 4 million plus 900,000 plus 30,000 plus 8,000 plus 800 plus 20 plus 7. This could also be 4 times 10 to the 6th power plus 9 times 10 to the 5th power plus 3 times 10 to the 4th power plus 8 times 10 to the 3rd power plus 8 times 10 to the 2nd power plus 2 times 10 to the 1st power plus 7. And the written form is 4,938,827. Our next one expanded is 9 million plus 20,000 plus 8,000 plus 700 plus 40 plus 2. And with our powers of 10, that'd be 9 times 10 to the 6th power plus 2 times 10 to the 4th power plus 8 times 10 to the 3rd power plus 7 times 10 to the 2nd power plus 4 times 10 to the 1st power plus 2. Our next one in expanded form would be 10 million, 2 million plus 2 million plus 800,000 plus 40,000 plus 7,000 plus 100 plus 20 plus 3. With exponents, that would be 1 times 10 to the 7th power plus 2 times 10 to the 6th power plus 8 times 10 to the 5th power plus 4 times 10 to the 4th power plus 7 times 10 to the 3rd power plus 1 times 10 to the 2nd power plus 2 times 10 to the 1st power plus 3. Written out, it would be 847,000 is what it should say. Okay. So next we're going to do the blue square. It says write the following numbers in standard form. We just went over what standard written and expanded form is, and then you need to fill in the chart below with the written and expanded forms. I think we all get this pretty great. I'm not going to go over it in super detail. Here's your answer key. Feel free to pause on any of these to kind of get a better idea. I'm going to go over the expanded forms. So the first one, the expanded form, could also be 8 times 10 to the 6th power plus 9 times 10 to the 4th power plus 2 times 10 to the 3rd power plus 3 times 10 to the 2nd power plus 8 times 10 to the 1st power plus 4. For 400,082, the expanded form could be 4 times 10 to the 5th power plus 8 times 10 to the 1st power plus 2. And for our last one, which is 987,654, this would be 900,000 plus, it would be 9 times 10 to the 5th power plus 8 times 10 to the 4th power plus 7 times 10 to the 3rd power plus 6 times 10 to the 2nd power plus 5 times 10 to the 1st power plus 4. Whew, it's a mouthful. Remember here, guys, that and means the decimal point. I know I am guilty of accidentally saying like 123, but it's really a good habit to get into to only use that and when you're talking about a decimal. Okay, so now our black diamond. Our black diamond is optional. You have a choice. You can either do the black diamond or you can do, you may of course do the double black diamond. You can either do the double black diamond and skip your IXL, or you can do IXL and skip the black diamond. So your choice. Number 1, I'm thinking of a 3-digit number. If I multiply it by 2, it becomes a 4-digit number. What is the smallest number I could think of for this sentence to be true? So I need to think of the smallest number that's 3 digits that I could double that would get me a 4-digit number. And then you need to write it in standard, expanded, and written form. That one's kind of a puzzle, so I'm not going to help you. Number 2, what is the smallest number I would need to add to 1 million to make it an 8-digit number? Write that number in the following form: standard, expanded, and written. What is the largest number I could write with the digits 1, 2, 3, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9? Write that number in the following forms: standard, written, and expanded. What is the largest number that I could form by only adding 2 3-digit numbers? Write the number in the following terms. So what's basically the largest 3-digit number I could make? And then what would that be if I added them together? Number 5, I'm thinking of a number. When I divide it by 2, it is half the number of digits as my starting number. So for example, if I started with a 4-digit number, I need to end with a 2-digit number when I divide it by 2. What is the smallest number that this could apply to? So you really want to think of maybe 2-digit and 1-digit numbers. 462,941,862,503 is equal to which of the following? So you need to fill in those blanks in the expanded form. And same thing for number 7, 520,008,263. How could I fill in those blanks to make that true? So the 500 million is already filled in for you. So the next thing I need to fill in is 20 million, for example. And here are my answers. For the first part, pause on the screen if you need to. Here are my answers for the second part. Pause on the screen if you need to. Thank you, everyone. Whoop, backing out. Thank you everyone so much for joining me and for working hard today, and I will see you in a little bit for science.